All right, guys, it's Jillian here, and we're going to multiply and divide some fractions. Multiplying and dividing fractions is identical. It's all the same, just the dividing part has one additional step. That's it. So when we are multiplying or dividing fractions, we are going to, let's start with multiplying. We're going to multiply the numerators, write down the answer, and multiplying the denominators. So really treat it like it's just two questions. 1 times 3 is 3, and 2 times 7 is 14. That's it. Okay? Seriously. You can do that. Now, let's take a look at dividing. What's this extra step I was talking about? Well, here, what we're going to do is we copy down the first fraction. We change dividing to multiplying, and then we flip, or the proper term is take the reciprocal fraction. Reciprocal. So now what we're going to do is we're going to multiply the numerators and multiply the denominators. 1 times 3 is 3, and 3 times 5 is 15. And in this question we didn't reduce our fraction. There was nothing to reduce, but in this question we can. We always, no exceptions. If your teacher tells you not to reduce fractions, I want to know about it because I don't believe you. Like, honestly, everyone reduces fractions. It's just the way we roll. So, what number goes into 3 and into 15? Of course, actually, the proper way is to line up your equal signs so that they're all in a row vertically. So what number goes into here and here? 3. So 3 goes into here once, and 3 goes into here 5 times. Now, I want to show you something. Going back up here. Over here, let's take a look at this and just go that away for a second. You can cancel when you have a fraction times another fraction. So you've done the flip if it's a divide, or you didn't have to because it was a multiplication of two fractions. But when you have two fractions and they're being multiplied together, you can reduce before here. You can look here and you can say, well, anything in the top reduced to anything in the bottom? Yeah. 3 over 3 can be 1. 3 over 3 is equal to 1. So if that's the case, what you do is you replace these 3's with 1s. So you have 1 times 1 and 1 times 5, which of course give you that. Okay? So you can either multiply it out and reduce, or you can reduce and then get straight to the answer. I'm going to tell you that at the beginning you might want to do this, but as soon as you can, start being able to do this, and you're going to find you're doing a lot less complicated math in your head because the numbers are smaller because you're reducing. Okay? Next one. Let's see this. Well, what's 6 in a fraction? Well, you know, if you just put something over 1, it's a fraction. So there you go. Any number on its own, just put it over 1. So now we've got 6 over 1 dividing, so we're going to times and flip. Now, is there any reducing we can do? From here to here, here to here, of course, any denominator to any numerator, so there is. 3 goes into 3 once, and 3 goes into 6 twice. So now we have 2 times 4 is 8, and 1 times 1 is 1, and we don't leave it like that. In the next line, we go like this. Okay? Now, lastly, on this page, we're going to take a look at this one. So we have here, hang on one second, we're just a bit twisted. Okay, so we have a dividing sign, so we're going to keep this one the same. We flip this one. We never, ever, ever flip the first one. You copy it down, change it to multiplying, and flip. That's the pattern. So, let's see, is there anything to reduce? Well, 11 and 3, no. 2 and 11, no. 2 and 9, no. 3 and 9, yeah. 3 goes into here 3 times, and 3 goes into here once. So now we've got 11 times 3 is 33, and 1 times 2 is 2. And then we look again to see, can we further reduce? In this case, we can't, but let's say you didn't pick the biggest number to reduce by. You might have missed something, and then there you've got something else to reduce. In this case, you do not.